Alright, so in today's video I'm going to be showing you guys how to find a tornado on radar. Now, for people wanting to go into meteorology, this is a great one. Now obviously this is kind of more on the complicated side of things, but basically you want a hook that kind of looks like this. Now not every hook is going to look exactly like this, obviously. Every radar scan or every radar that shows a supercell thunderstorm that is rotating is not just going to look like this every single time. But basically here's your reflexivity here with a very good looking hook echo. Your tornado is going to be located somewhere in the southeastern part of the storm, and then this is your velocity couplet. So the velocity couplet shows winds going basically towards the radar and away from the radar. The red indicates winds going away from the radar, and the blue indicates the winds going towards the radar. This is what we call a debris signature, also known as correlation coefficient. Basically, we are looking for something that lines up exactly with this supercell thunderstorm, basically exactly where this is. So we're basically looking for a blue splotch on this radar in the spot that aligns with the actual thunderstorm itself. So this is a video. We're still waiting for it to kind of show up on that radar, and it's not showing up very well. But you can kind of see it there. It's right here. It's very hard to tell. But there's your blue splotch right there, and it kind of lines up exactly in kind of that general area where that thunderstorm is circulating, right there. And there's your velocity couplets again. So the velocity couplet, this one is right on the stronger side of things. So this is basically wind. So this you don't take it's very strong scenarios and very strong tornadoes. You see a radar couplet that kind of looks like this, maybe even stronger. This is very strong winds going away from the radar and towards the radar. This is like easily 65, 70 to, I'm trying to think here, 70 to 80 gate here. So 70 miles per hour going towards the radar and 80 miles per hour going away from the radar, or the other way around. Basically the same thing. Anyways, so that indicates you have rotation. Now, not necessarily is velocity couplet and a radar signature like reflectivity showing a circulating thunderstorm. Not necessarily every time you have to have a hook. There's also other scenarios like I'm about to show you. So there's another thing that is called there's another tornado kind of that goes along in the linear with thunderstorms, not so much individual cells like you see on radar, sometimes with scattered thunderstorms, but more in the line of a thunderstorm. Not necessarily derecho, by the way, we can get into derecho in a whole other video. But basically we are looking for this kind of particular cell near what appears to be Garfield. I know. Iconic, I know. Relatively iconic and relatively, I know you're probably thinking of a cat, but in this scenario, the town is actually called Garfield. So, we're actually watching this line of thunderstorms move through. So as it goes through, alright, so here's a good idea. So it's rather hard to tell with a QCLS tornado effect. Remember, a QCLS is kind of embedded within the line of thunderstorms rather than just being widely scattered thunderstorms. So your QCLS tornado would be somewhere in here where the rotation is, and that's exactly what it shows here. So you have, when you get a rather tight couplet like this, like this is red going towards the radar and green going away from the radar, it's kind of hard to tell, but right here there's actually a little bit of a tight little couplet here of both direction winds. This is what we call a QCLS tornado threat.